Okay, so can I get started? Right. Okay. So hello everyone. Thanks for coming here. Now I think Kubernetes it's actually a pretty hot topic right now. So I'm really happy that we have a full room. I was thinking about starting with something which is unrelated from the topic, from my talk. So at 3 p.m. I was wondering if anyone wants to have like a chat about Kubernetes or anything connected to the CNCF. I will be waiting in the, I don't know, downstairs. Downstairs in the main room, and we can meet and we can have any sort of one-to-one chats. Okay. Why? Because I think that yes, having a generic talk it's interesting, but the real value is in one-to-one interaction. So let's start about this talk. What am I going to talk about in this talk? The cover image, it's actually the very starting point. I want to say that why did I put up some people just going up to a mountain? Wonder. Because actually, our job is not about being ninjas, but it's more about being Sherpas, okay? So it's more about dragging the business to the top. Remember, ninjas, they arrive, kill everyone, and disappear in the fog. So we don't want to be ninjas. We want to actually deliver tested solutions which are generating value for the business. Who am I? My name is JACOPO Nardiello. I'm from Italy, from Milan. I've been working for a number of years in London. That's my son. Why did I start with my son? Because it's cute, and because he has a Kubernetes t-shirt. So I'm the founder of JACOPO. We are, later, I will just now explain what we do, but basically we are a cloud-native startup, so what we do is Kubernetes. We are fully focused on Kubernetes. More importantly and more interestingly, I'm a CNCF ambassador. What does that mean? It means that I spend a lot of time discussing, mainly understanding all the projects in the CNCF galaxy and how they can integrate and how they can deliver value. So another thing that I do, which is can be interesting if you ever happen to visit Italy. I'm also the organizer of the Kubernetes and Cloud Native Milan meetup. So if you happen to have time and are willing to visit Milan, just ping me, and we will be really happy to have you with us. So before, during the keynote, the guy was talking about DevOps and automation engineer. Wow, DevOps engineer, it doesn't exist. Maybe, but I'm actually an automation engineer. That's what I measured in school. So that's +1 for me. So JACOPO, as I mentioned, we are a cloud-native company. What does it mean? It means that we basically battle test Kubernetes, okay? What we do 100% of our time is to be focused on Kubernetes and to make Kubernetes work for production environments. It's a huge challenge, and that's, as I said, 100% of our effort. So Kubernetes, it's a topic that it's really hot right now, as I mentioned. But I mean, there is a lot to say. There is a lot that can be said later on. In this talk, I'm going to scratch the main things, but later on we can have more focused discussion. I want to mention actually that we are we are an open source company, meaning that we work only with open source stuff, okay, and we try to contribute back. It's really hard because we have no VC investment, so we need to be profitable, but we try to do that. The only corporate partnership that we have is with HashiCorp. HashiCorp, do you know what HashiCorp is? Terraform, Vagrant, just to name a few, okay? Right, so where do we want to start? How many of you are actually working with containers, and how many of you are actually working with Kubernetes right now? Okay, cool. I was expecting more people. That's interesting, okay. So Kubernetes, you want to get started with Kubernetes, where do you start? You start from the homepage of Kubernetes.io, right? What do you read in the homepage? That's like great piece of marketing. You read some pretty bold statements here. Production grade container orchestration, automated deployment, scaling and management, planet scale, never outgrow, run everywhere. Right, so I think honestly that these are kind of bold statements from the Kubernetes projects. Why? Because when you start with it, yes, it's not really the kind of project that you just take off the shelf, boot, and it works and it gives you all this stuff. But it is true that if you actually dedicate enough effort on it, it can reach that kind of it can be up to to what they promise. So when you start, you are we are all actually a little bit like this, yeah, we start with Kubernetes, yeah, fantastic. We are the cool guys playing around with the latest hot project. But then as you actually start to work on it more consistently, after a few months, you can very easily end up like this, right? Just banging your head, not sure what you're doing, just trying to make things work, but you realize that you are bringing home more complexity than the problems that you are actually trying to solve. So why this talk? It's very simple, because I want to give a general yet informative and practical advices on how to debug Kubernetes. Before starting right on with the Kubernetes part, I want to start with the basics. And I'm sorry if this is too generic, maybe for some of you, but I think it's really important actually. So I want to start with what is a container? Does anyone want to tell me what is a container? So basically a container is just a tarball, okay? It's a tarball, gigantic tarball, which includes not just your application stuff, not just the application dependencies, but also all the system dependencies. Why is this important? Why do you need to have clear what is a container? Because when you are actually running Kubernetes, obviously in production, but also when you are powering all your infrastructure with Kubernetes, you need to have an idea of, you need to be able to actually have a very, very strong feeling about the stuff that you are working with. So you need to be able to interact with the container, to have, sometimes, containers, they have this kind of magic. So I don't know what is a container, and I try to kind of debug stuff that is supposed to work, but that actually doesn't work. If you have clear what is a container, this is going to make your life a lot easier. Why containers got started in the very first place? Where containers, so Kubernetes is starting from Google, right? Google has started Kubernetes as a third iteration of their orchestration framework. The very first iteration was Borg, then they tried to iterate with Omega, and Kubernetes was the third attempt to actually have something to orchestrate their own infrastructure. Then later they open sourced it. But why is Google using Kubernetes? This is unplanned. I just want to tell you a little bit of history because that's important as well. So for one simple reason, because when Google started, VMs were not there, were not a thing. So they had a very specific problem to solve. They had to run their workloads on bare metal machines, and they had to find a way to isolate processes. Why? Because when you have like a bunch of processes in a machine, you can have any sort of interaction. So the whole container thing is actually a way to isolate a process running. Okay? What are containers made of? Containers are not first-class citizens, okay? Meaning that there is no concept of container in the Linux kernel, basically. They are just a collection of stuff of existing technologies. So control groups, C groups, this is a technology powered by Google as well. Linux namespaces, file system versioning, I just call it like black magic because that's stuff I really don't know. And then, of course, you have the runtime. The runtime, it used to be Docker. Docker was, in this whole talk, I'm not going to mention Docker, but I need to give credit to Docker. Docker was a turning point. Why? Because they actually made containers usable by the average developer, okay? Before, you had to manage all this stuff just by yourself. That was not feasible for any team, right? Unless you were Google scale. But with Docker, this whole thing actually changed. So I have actually a question now. Why running a single process in a container? That's kind of a best practice that you hear a lot about if you're running with you get started with Docker, you play around with Docker Compose, microservices, blah, blah, blah. Sure. But I mean, beside the philosophy. Why? For one simple reason, that the Docker daemon is actually going to process, the main process is going to monitor, the main process that you're starting out. So imagine that you have a container where you have more than one process inside running, okay? You have PHP, Nginx, and MySQL, a full LAMP stack. That's very, standard. What happens if your MySQL stops to work? If it stops to work, you are actually stopping to have a working service. So your service is going to return just 404 and that's it, right? Or internal server error or whatever else. But actually the container is going to keep running fine. So the daemon is not going to understand that there is actually a failure. That is why it is important to isolate processes, okay? The fact that this fits very well with this whole, microservices thing, it's just a side effect, okay? I mean, don't get me wrong. Writing code in microservices is super important. It's just not our focus right now. I'm just trying to give you a reasonable explanation of why this is a good practice, okay? And I'm very surprised that you don't read about this stuff around. There is a lot of people saying, yeah, it's better to isolate for whatever reason, but there are really practical reasons for this. Right, okay, so let's dive deep into Kubernetes. This is like the mandatory slide. Whenever you're talking about Kubernetes, you need to bring the Kubernetes architecture. But usually I really don't like to include it, but this time I thought that it was actually critical. Why was it critical? Because this is actually a really good design, architecture of Kubernetes. It's showing all the pieces, okay, and it's showing how they talk to each other. So this is not something I want to quickly mention. I actually want to spend some time explaining you how the Kubernetes architecture is composed and how the pieces are talking to each other. Because why? Because running Kubernetes in production, it's about running this stuff. And it's about having control of this stuff. So basically you have two macro components, okay? You have the master, you have the workers. I guess everyone knew kind of that. What is interesting? It's interesting that the master, it's actually a number of services. So running Kubernetes in the end, I think I mention it as well later in the slides, but running Kubernetes, in the end, it's about running a distributed system. So never forget, you should always remember that running Kubernetes, it's nothing else than running a distributed system, so different microservices with different concerns talking to each other with a shared state. That's it. So we have the state, which is stored in etcd. etcd is a key value store. Probably you know it. And then we have the core of the whole infrastructure, which is the API server. So Kubernetes is all about abstracting away your infrastructure with APIs, right? That's the job of the API server. Who is talking with the API server? Everyone. So all the other services are actually talking with the API server. The control plane is then composed with two other components, which is the controller manager and the scheduler. The controller manager is the one iterating the so-called control loop, which it means that it's reconciliating the state of your infrastructure to the desired state. So if you try Kubernetes, you have your deployments, you have a very, so you just declare the declarative way of running your infrastructure. So you say, I want to run this service with this number of replicas, blah, 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 right? The controller manager is the one understanding if you need to scale, how much you need to scale, if you need to operate any kind of change in your infrastructure. And then we have the scheduler. The scheduler is the one actually binding our pods, the containers, okay, running to the infrastructure. Then we have, this is just a control plane. Why is this important? Why did I spend time talking about this? Because having a reliable battle-tested, let's call it battle-tested, installation of Kubernetes means to have a reliable control plane. So the worker nodes, they are sacrificable. I'm not sure if that's an English word. Well, I mean, you can sacrifice them. You can just shoot down a node, bring back another one, that's fine. You know, Kubernetes is going to handle the migration and it's going to give you some free stuff. It's going to keep you alive, let's say. But if you lose a control plane, you lose your cluster, okay? So that's, you know, you need to be really careful with that. And we are going to see what are the pieces that we need to say. Well, let's mention it right now. Actually, so the control manager, API server, and scheduler are fully stateless. They don't have any kind of state. Scaling the API server, it's easy because it's stateless. Okay. The really sensitive part is about etcd. So etcd, it's where the whole state of your infrastructure is stored. And if you want to have like a safe installation, that's the part that you need to be careful about. Sorry, just getting back to the worker nodes. The worker nodes are essentially composed by two running processes, which are the kubelet and so-called kubeproxy, which is going to handle the cluster-wide virtual VLAN, so the networking part. Then we have the container runtime and the OS. Okay, container runtime. Why don't I mention Docker here? Well, for one simple reason, is that Docker is just one of the possible runtimes that you can actually use. Okay, in the past there have been problems with Docker. So for a really long time, Kubernetes got stuck with Docker 13 something. Why? Because Docker is not meant to be for Kubernetes. So as they made new Docker releases, they actually broke compatibility with Kubernetes, and that was actually a really big problem. Right now, it's better. But the fact that in the past we had this situation brought to a situation where multiple runtimes got started. And I want to mention one which is developed by Red Hat, by one of my friends, which is CRI-O. So OpenShift, it's going to soon drop Docker to actually adopt CRI-O as a main runtime engine. CRI-O, it's CRI-O, okay, that's how it's written. It's actually meant to be a runtime engine just focused for Kubernetes. So it's going to, to follow Kubernetes along with its development. Right, so going forward, what are the challenges? The challenges, we have to divide. You can see Kubernetes as a line of, division. You have the stuff that you run on top of Kubernetes, and then you have the Kubernetes component, so Kubernetes itself. We can further actually split all these parts, and the main challenges are, that we can find are about, of course, your services and applications, but I'm not going to talk about them specifically right now because those are your applications. But then we have monitoring, alerting, logging, and the stuff which is powering Kubernetes. So the Kubernetes services, the architecture that you are going to choose, and the cluster lifecycle management. These are, in my opinion, the most critical parts that you need to handle whenever you decide to deploy a battle-tested Kubernetes. Let's dive into it. So picking the right architecture. These are the factors that influence the most having the correct architecture for your Kubernetes. So decide what is the correct availability model for your application. We're going to see in a minute what do I mean with that. Having a lifecycle management. So lifecycle management, it's something we will briefly discuss, but I was really surprised 2 years ago when I got started, okay? Everyone was just jumping right into Kubernetes. Yeah, let's try it, let's use it, let's deploy it to production. How do you update your cluster? How do you, if your cluster end up in a state which is not the state that you want, how do you keep it running? And people were just staring at me, and nobody had a clear answer. And why? Because back then, there was absolutely no tool to manage Kubernetes. So Kubernetes 2 years ago, the only way to actually provision a cluster was either spend a lot of time and resources provisioning it on your own, or running a gigantic bash script, which is called kubeapp.sh, which was going to eventually do everything, okay? I mean, that was completely unacceptable for us. So back then when I started, there was no other option than just getting the single pieces, understanding how they were working together, and actually take control of them. So another really important thing is about backup and disaster recovery. Okay, this is something that you probably want to understand and to at least have an idea of how to tackle. And then you have storage and networking. So storage and networking, it's actually a really good candidate topic to discuss this afternoon, because it's such a big topic that I'm just not going to mention it too much in the presentation, but it's actually a really important thing. Networking means essentially deciding how the virtual LAN of your Kubernetes cluster is going to be allocated and what you can do with that. Why is it important? What if you want to have firewall policies? What if you want to have different level of accessibility to your workloads? So that's pretty important. And the storage part as well, because Kubernetes, one of the premises of Kubernetes is that, oh yeah, we're going to manage storage for you. Yeah, sure. Okay, I want to read-write many volumes. How do I do that with Kubernetes? So on AWS, for example, you have EBS, which is great. Kubernetes is going to handle that for you. Unfortunately, it's not read-write many. So if one of more pods, because you want scalability, I mean, you are choosing Kubernetes because you probably want to be able to scale. So what if more than one pod want to access the same volume? That's a problem that you have to solve yourself. Let's start with high availability. So what are the models about high availability? We have two main models, which is traditional HA, multi-master, and then we have the so-called mean time to recovery. I need to speed up a little bit, so I would just say that most of the times we have only one client which is actually implementing multi-master. 90% of the times, mean time to recovery, so MTTR, it's absolutely acceptable. What does that mean? It means what is the time that you actually need to recover the state of your cluster in case of a failure of the control plane. So what happens if the control plane fails? That's something I didn't mention in the slides, but it's worth saying that. Basically to your infrastructure, nothing. Okay, so your cluster, your Kubernetes cluster is going to keep working fine. Your services are going to keep doing whatever they have to do. What you actually lose is the ability to schedule new stuff. So 90% of the times, how long does it take for me to spin up a new master if my existing master fails? 10 minutes. Okay, for 10 minutes I won't be able to scale, to schedule new stuff, but that's totally acceptable. There are use cases where this is not acceptable. I don't know, really large corporation. We have a project with 800 developers. These 800 developers in a single project, they keep pushing and we have pipelines running. So is it acceptable for 20 minutes to not have any new job scheduled? In that specific use case, no. So that's the only use case I personally have where multi-master is actually a thing. So what is right for you? I don't know. It depends how critical is the project you're working on. Availability model. So this is just a visualization of what I just mentioned. This is like a multi-master architecture. In this case, one thing that I want to highlight, you see that we have the control plane, which means API server, controller manager, and scheduler on 3 machines in an auto-scaling group. We can spin them up. We have a load balancer in front of it. We can, that's a true multi-master. But also, we have a etcd on a separate machine. Okay? Separate machines. Why? Because etcd is just a DB. It's just a database. So it has its own life cycle. You need to manage it. And nothing stops you from deploying it on different machines with a different policy. It can be outside your cluster. Okay? It doesn't have to run within Kubernetes itself. This is the other option that I was talking about. So this is an example of a fast enough MTTR architecture. What does that mean? We have a single master with everything inside, but we have etcd running on an EBS volume, which gets snapshot once in a while, and which is where once in a while it's what is acceptable for you. And in addition to that, we have Arc cluster dumps outstored on S3. Okay. We're going to see what is, I'm going to mention what Arc is later on. Right, so we are a super critical project. We need to have availability 100%, 99.9999 SLA guarantee to our clusters. How do I do that? Fantastic. We have seen multi-master installation. That's going to take some effort from you. I'm telling you. Why? Because there are, it's difficult, still very difficult to have multi-master. Well, it's difficult to have a multi-master installation. But then you deploy it, fantastic, but you have just one single DNS. Huge failure. It doesn't make any sense. So why DNS are used to do, service discovery within the cluster. So basically, all the services deployed on your cluster are going to talk to each other, resolving DNS. So if you have a single DNS and this fails, all your processes stop to talk to each other. That's not through HA. So you need to be careful about bottlenecks as well. Moving on, lifecycle management. Lifecycle management, as I told you, it's a hell of a pain. Why? Because the environment, right now there are tools to actually provision new clusters and manage new clusters. If it takes 5 minutes to Google around what options you have, and I'm just mention a few. Kubeup SH, it's my trolling to you for today. But all the others are actual projects. So Kubicorn, it's kind of abandoned right now, I think. Kubernetes Anywhere, it's just fairly small. COPS, it's super large. There is another one which I actually didn't add, which is KubeSpray. The problem with all these things, with all these projects, is that they all started before KubeAdm, KubeADM. KubeADM is actually the only official project, and it's where the whole community is converging to manage life cycle, the life cycle of your cluster. So just guess which of these projects you should probably pick if you're starting today with provisioning new clusters. Just wonder, KubeAdm. So KubeADM is actually, as I mentioned to you, the core project right now. It has a dedicated SIG. SIG, it's a special interest group, so there is a specialized team working on it, and slowly COPS and KubeSpray are migrating to it. Eventually we will get there. The pitfalls. So the pitfalls of all these projects is that they are all absolutely great to provision new clusters. Updating, it's yet an unsolved problem. So updating your cluster and keeping it updated, it's not so trivial. KubeADM shipped recently. I think recently it's about probably less than 3 months. I don't want to be imprecise, but it's kind of a recent feature. The fact that it is going to manage the update, but again, it's not as battle tested as I wish it to be. Okay? Meaning that if anything fails, you're on your own. In the future, what is the Kubernetes community working on? It's actually working on one thing which is called cluster definition. So basically, we are going to have, in the future, ideally, we will reach a point where we have a large YAML file describing the whole infrastructure, so number of nodes, number of worker nodes, number of master nodes, number of etcds that you want to have, and you are just going to apply it, and you are going to have your cluster provisioned, and the same way it's going to work for the update. It's still like prototyping, so it's absolutely not something that you are going to see today. Oh my God, okay. But ideally, this is where we are going, this is the direction we are going. What is the big problem with this, with all this scenario, is that there is a lot of fragmentation, and that is something I really, really, really don't like. So, as I told you, what we do actually, it's to operate our own clusters, meaning that we have our own Ansible deploying stuff, Terraform and Ansible's deploying the control plane, deploying our own different possible architecture, and I suggest that you do the same. Why do I suggest that? Because it's very educational, so you are actually going to have a very tight control on your cluster. Again, don't get me wrong. Using KubeAdm, it's actually a really good idea, even if you start to operate your own thing, okay? So you might use KubeAdm, for example, to bootstrap the API server, controller manager, and scheduler, and then manage your own etcd, separately. That is something that is possible. Ideally, it's good to use KubeAdm. Why? Because as I mentioned, the whole community is converging there. What you need to, if you do that, what you need to be aware of. Funny defaults. So when you bootstrap, for example, the kubelet, okay, it doesn't have any dedicated resources on it. What does that mean? It means that if you, on the same server, are running other stuff, which is usually the case, right? If this other stuff is going to eat up all your resources, you're going to lose the node. And this is not something that you want to do. Be sure to secure your cluster. Security is something that has beaten a lot of companies. Tesla, to mention one, right? They had like hundreds of clusters exposed to the public with no authentication. Why? Because Kubernetes, by default, it doesn't use, I don't know, certificate. You know, all the certificates management in Kubernetes is still something that has to be improved. Only recently, I think since version 1.7, they introduced basic auth and token authentication on the dashboard of the control plane. So there are a lot of stuff that you need to be careful about. But most importantly, if you are going to operate your own thing, you need to follow what the community is doing. What about managed clusters? This is a depends. It depends. So the answer to this question is, okay, I want to get started with Kubernetes. What if I start with GKE or EKS or any other turnkey solution, right? It can be really good. There are different, each cloud has a different level of maturity on this. Rancher 2.0, it's pretty good. GKE is by far the best. I'm sorry, Alex. EKS, it's kind of it's good. We have been waiting for it for a long time. We don't use it on our clients, even if they are on AWS, for one very simple reason. I don't know how the update is going to work. What does that mean? It means that on EKS, so GKE is going to handle mass control plane and the worker nodes, right? You are going to the updates. They are going to handle them 100%. With EKS, that's not how it works. So with EKS, you are just purchasing the control plane, and then the nodes are on your own. What happens if there is a new version? They're going to provide the update of the control plane and the TCD for you, but then your nodes stay behind. That's an open question. I don't know. We are going to test it a little bit. It is something that you need to keep an eye on. Of course, managed clusters like this are going to give you, as I mentioned, a lot of benefits, networking side and storage side. Again, on Amazon, for example, the networking, in my opinion, is not really amazing for one simple reason. They are binding their, I think it's, well, their interfaces, okay, their network interface on the nodes. They're binding them inside the Amazon cluster, inside the Kubernetes cluster. What does that mean? That each pod inside the cluster, the Kubernetes cluster, is going to have a VPC EP. Do you know what I mean? So basically, you have like your own isolated networking, and each pod is going to get an IP on this networking, and it's not going to have a separate network like in standard clusters, okay, in standard AWS cluster. This introduces a limitation because you cannot schedule more than 17 pods per node. It's nonsense. So I think it's going to take more time. Oh God, okay, 1 minute it's, okay, I will just run. Backup NDR. We have two levels of backups that we can run. The very first one is the low-level backups. As I mentioned to you, you have your node, you have your etcd running on it. You can just take snapshots of the volume, and in case of a failure, you just spin up a new instance with the attached EBS or a recovered EBS from one of your snapshots, or you can take raw dumps of etcd. But then lately, and luckily, there is this new tool. It's not really new, but we started to work on it quite recently, which is called Arc. Arc is a project from Heptio. Heptio is one of the companies working on Kubernetes, but it was founded by the founders of Kubernetes itself. So Arc is actually really cool. Why? Because it's not going to just snapshot your etcd, so the state of your cluster, but it's going to actually take a full cluster dump, and it's going to back up also all the persistent volumes that you have. So it's going to back up as well the state of your running pods. Then we have a lot of other small details, okay, that you should probably care about and that we can discuss later on. For example, as this already mentioned, limit resources. So you should always, that's my really an advice that I give you, limit your resources on your pods. When you're running a pod, when you're running a deployment, you can specify the requests and so-called limits. The requests, these are used to actually schedule your pods, but the limits are the ones that are enforced on your running pods, meaning that if you have any strange behavior, it's going to, the OOM killer, it's going to intervene and kill the so-called bad workload. So treat your cluster logs as just regular logs. I told you, all this, it's about running a distributed system, it's about running a distributed system on Kubernetes, it's running a distributed system. So your Kubernetes services are going to generate logs. Ideally, you want to collect them and just treat them as regular logs. So instrument fluentd. In our case, we use fluentd, but it's standard from the CNCF, and it's working really well, by the way. Just instruct your fluentd to gather the logs generated by Kubernetes. So these are security-wide stuff, so if it is possible, disable privileged containers. That's not always possible. Disable the default service accounts on your pods. So by default, all the pods can run commands against the control plane. So if any of your pods is going to be compromised, the whole infrastructure is actually compromised. But you can disable the service accounts which are binded by default. Disable or change them at least, the policies. And yes, so, and then work with airbag and the pod security policies that you can assign. More on this. DEX. DEX, it's a project, it's a tool to actually manage the authentication and authorization on your cluster. Basically, it's going to allow you to manage the authentication and authorization on your cluster using your existing system. For example, you have GitLab, you have LDAP, you have GitHub, you have whatever else, okay? DEX is going to create users, okay, policies, access policies to your cluster based on what you have on your authorization and authentication. And then plan rollout strategies. By default, there are some defaults when you have deployments. Rollouts, automatic rollouts are one of the big reasons to choose actually Kubernetes, right? But the default strategies might not be right for you. Maybe because they're going to break the database, your DB, maybe because they're going to cause downtime, for a number of reasons. Just verify them. And then abstract external services. So you have an external DB. Instead of calling directly the endpoint, just create a so-called external service in Kubernetes. Why? Because if tomorrow you're going to bring your external services within the cluster, you're not going to have any other change. There are good things in Kubernetes, of course. So this stuff is actually what we use routinely. These are all projects within the CNCF or widely adopted. I'm referring to Nginx. You can definitely use them. I mean, Prometheus, fluentd, Helm, CoreDNS. Helm, for example, we don't really use it that much. We use a new tool, a project called Customize, and we can talk about it later. The only important thing is that you actually don't run the defaults. I see a lot of people just doing Helm chart install, blah, blah, blah. Right? Okay, what is that? I mean, it is bringing up something. You're going to have some amazing Prometheus running out of the box. Fantastic. But what is the configuration of that Prometheus? Verify it. Maybe it's fine, the default, but probably it's not. So let's wrap it up. The very first thing that I want to tell you is that there is no magic. Kubernetes is just a bunch of processes running on your nodes and abstracting away your infrastructure. So keep that in mind whenever you have problems. Get inside your nodes, see the processes running, and debug them. Kubernetes is a complex beast. Of course it is. But again, take time to actually learn the architecture. Take time to actually learn the pieces. Take time to actually learn the flags that you can have running your, for example, on the kubelet. Okay? There are tens of them, and you probably should know them if you're running Kubernetes in production. And then leverage the community, but don't blindly trust it. Okay, so just use all the charts, use all the catalogs, use whatever you want, but inspect everything. Why do I say that? Why do I say that? Because believe me, there is a lot of people which is just doing, running defaults and not thinking about what that implies, because that is fast, but that's not right. That's it. Questions?
A quick question. We have run out of our time.
I guess I have one question. You said the whole community is moving to kubeADM, but does it also cover networking stack and all that stuff like kubespray and the others do?
Sorry, can you just say that again? I didn't.
Does kubeADM also cover setting up networking and all those components?
No, it doesn't.
Because that's actually the strength of Tarmac and kubespray and cups and all of those things.
Yeah, but you want to have control on that stuff. So Tarmac and kubespray, for example, yes, they deploy funnel, for example, out of the box, right? But funnel, for example, does not allow to use any networking policy. So you need Calico for that. So how do you take control of it? The Kubernetes philosophy is not to be opinionated on the networking. So that's why they use interfaces. They have the container network interface. They have the container storage interface. So kubeADM, it's just to bootstrap. That's actually a really good question. So kubeADM, it's going to bootstrap a plain Kubernetes cluster. But then you have to have it working. You need to deploy stuff on it. Core DNS, it's not going to be there. It's going to, if you want a DNS, you need to deploy Core DNS by itself. The same goes for the networking. You may, it's going to bootstrap a cluster, but then if you want to have pod-to-pod networking, you need to install WeaveNet, Calico, you have Cilium. There are a number of projects, okay? You need to invest time. It's going to be expensive migrating Kubernetes because you need to invest this stuff, to investigate this stuff and understand which one is best for you.
All right, it's better to use break time for questions. And thanks for Mr. Jacob for joining us for his speech.
Thank you.
Here's a small gift from the team.